Coral reefs is the most biodiverse and productive ecosystem on Earth, providing critical ecological, economic, and cultural benefits. However, these ecosystems are increasingly under threat from human activities and environmental stresses, leading to widespread degradation. The coral reef of the Koto Archipelago in Vietnam was known for their high biodiversity, have experienced severe degradation with over 80 of species and 90 of live coral cover lost between 2002 and 2006. This decline was primarily caused by cyanide fishing, which devastated the reef and left many areas unable to recover naturally.
Let's begin by discussing the problem. The coral reefs in the Koto Archipelago, Vietnam, have faced severe degradation. Between 2002 and 2006, nearly 80% of coral species and over 90% of live coral cover were lost. This alarming decline is largely due to cyanide fishing. This situation is critical because it threatens marine biodiversity and the livelihoods of local communities that depend on these ecosystems. Now, why is this issue being studied? First, there is ecological importance. Coral reefs are vital for supporting marine biodiversity, providing habitats, and maintaining ecosystem balance. Second, the reefs hold economic and social relevance as local communities rely on them for fisheries and marine resources. Finally, the study aims to achieve scientific and conservation goals, including understanding the causes of coral degradation and exploring effective restoration techniques. Now, let's move on to the objectives of this study. First, assessing the current condition of coral reefs, including the extent of degradation and biodiversity loss. Next, identifying the main causes of reef degradation with a specific focus on the impact of cyanide fishing and other environmental factors. Another goal is observing natural recovery processes such as coral growth and recruitment to evaluate the reef's capacity for self-restoration. Additionally, the study aims to evaluate the success of coral transplantation efforts on artificial and natural structures by measuring survival and growth rates. Finally, the study will provide recommendations for effective management and restoration strategies to rehabilitate damaged reefs and prevent further harm.
For this study, there is three-step methods that were taken. First is determining coral status and degradation. Observers were towed over the reef using a small boat to record data. Specific surveys were conducted using the point transit method to collect detailed data on substrate components. Environmental monitoring were also taken by observing water parameter and water quality at the different sites. Second step is monitoring natural recovery. Growth rates of surviving coral colonies were measured annually using labeled colonies and fiberglass rulers. Transit line was set up at 5 reef sites to count small coral colonies and observe juvenile recruitment. The third method is artificial restoration techniques. Two types of shelter were used for coral transplantation. First is artificial shelters. Concrete reef walls were designed with holes for coral planting and space for marine organisms. Coral fragments were tied to these shelters and deployed in the sea. Second is natural shelters. Coral fragments were tied to dead coral rocks using steel nails and plastic ropes for transplantation. Coral fragments were sourced from donor reefs in the Koto area, focusing on massive encrusting and laminar species, since branching corals were no longer available.
On to the causes of coral degradation. The water quality in the study area remains stable, with parameters such as temperature, salinity, dissolved oxygen, pH, and turbidity within acceptable limits. Nutrient level including ammonium, phosphate, nitrite, nitrate, and organic matter, as well as pesticide comply with Vietnam water quality standards. However, cyanide pollution continues to pose a significant threat to the reefs. Cyanide level averaged from 4.95 mg per liter, where exceed both Vietnam standards. Cyanide is highly toxic to human, animals, and marine life. Between 2002 till 2006, fishermen used cyanide to capture fish, with around 100 boats applying 2 till 10 kg of cyanide powder daily. The impact on coral reef has been severe. particularly affecting Acropora species. Although cyanide fishing is stopped, cyanide level remain high, reflecting enduring environment damage. Next is the discussion on natural recovery. Coral recovery in the Koto Archipelago has shown mixed results. Juvenile coral requirement is low in reef with few leaf coral with only 1 to 2 colonies per year, but higher requirement occur in reef with more leaf coral with rates reaching 23 to 28 colonies per 100 meters square per year. Natural recovery through growth has been observed, with surviving colonies grow at 2 to 3 cm per year. Those species like Corites and Pseudocytheratria tayami grows at a slow 1 cm per year and 0.5 cm per year respectively, with a maximum size of about 16 cm. Key challenges to recovery include persistent cyanide pollution, the loss of fast-growing branching corals, and reliance on slow-growing species for regeneration. As a result, natural recovery remains slow and rehabilitation effort will require significant time, primarily due to the absence of fast-growing corals.
To restore degraded reef, artificial shelter like reef ball and natural coral rocks were used as base for coral transplantation. First, look at the result for reef ball. A total of 130 reef balls were developed across 3 sites with 231 coral colonies planted. In the first year, survival rates were especially high at over 95%. However, some colonies were lost due to shock during the separation process or poor attachment. By the second year, survival rates dropped slightly to 88.3% due to an outbreak of the predator snail Rubella sp, which feed on coral tissues. On the other hand, coral transplanted onto natural coral rock showed a lower survival rate and only 55.9% after 2 years. This was mainly due to difficulty in securely tying coral pieces underwater, especially for massive and laminar coral sheets. Additionally, injuries from the transplantation process attracted Rubella sp, further reducing survival rates. When comparing the two methods, reef ball clearly have several advantages. They offer higher survival rates, easier handling, and better attachment, which help reduce detachment and predation. However, challenges still remain. Predator snail outbreaks such as those caused by Rubella sp need to be closely monitored. Additionally, care must be taken to avoid over-harvesting donor reef, as this could impact their health. Reef balls show great promise for large-scale coral restoration, but managing threats like predator snails and improving methods for natural coral rocks will be critical for future success.
Next, the importance of this study. This study is very important to identify the main cause of coral reef damage. The use of cyanide in fishing results in mass coral mortality, particularly in sensitive species like Acropora. It is leading to loss of marine habitat and reduced biodiversity. Natural recovery of coral is limited by the lack of larval sources on completely dead reefs, which requires rehabilitation efforts through human intervention such as coral transplantation using artificial shelters like reef balls. This method has proven to be more effective because it has a higher survival rate and lower risk of predators. In addition, even though the physical conditions of water are favorable, the presence of cyanide in water remains a threat, making pollution control crucial. This finding provides an important contributions to the development of conservation policies, including bans on the use of toxic chemicals and increasing public awareness of the importance of maintaining coral reef ecosystems. Next is suggestions of this study. To improve the effectiveness of coral reef conservation, long-term analysis that monitor natural recovery using advanced technologies such as satellite imagery are needed. Further studies should also focus on the impact of cyanide residues in sediment on coral regeneration. Developing more efficient transplantation methods would help to facilitate large-scale rehabilitation at lower cost. Investigating socio-economic factors could provide insight into the motivations and challenges that faced by local communities, as well as exploring incentives that could encourage sustainable practices. Studies on ecosystem interactions would help understand how coral reef ecosystems are connected to their surrounding environment. Lastly, evaluation of existing protected areas will ensure that coral reef protection efforts are effective and contribute to overall ecosystem recovery.
Coral reefs in Koto Archipelago suffered significant degradation from 2002 to 2006, reducing the number of species from 127 to 25. With nearly 80% of species, 90% of leaf coral cover, and 100% of some reef loss. The highest current coral coverage is only 7.5% compared to previously at least 50%. The primary cause of coral death was identified as the use of cyanide poison by coral fishermen, which severely affected sensitive branching corals like Acropora. Natural coral recovery is slow, with no recovery on completely dead reefs due to a lack of larvae, while some living reefs show a high coral recruitment. Restoration efforts using artificial shelters such as reef balls showed higher survival rates, 88.3% compared to natural substrates, 55.9% due to reduced predation.